Hey folks, it's Martin again. It's been a long day today, but I think I'm enjoying the creation of these video series because I'm kind of energized to get into it. So let's go. This is about what are the parts of our application, like what are the pieces that click together to make up our Lego optimization application. And it turns out that the answer to that question is very similar to the answer of what are the pieces of any optimization application. So this here, do you like the colors? I like the colors. They took me a while. This is just an overly pretty version of something that was quite handy to me, a framework, simple as it is. It was handy to me all those years at Ample, about 5 years at a particular desk, where companies would bring us models that were struggling to perform as quickly as they needed to or were broken in some other way. And we needed to quickly find out what's what in the tool chain and then begin remediations, right? So obviously we need a CPU or many CPUs. We need some memory, RAM, right? If we run out of RAM, we're going to need to use virtual RAM on a hard disk, but happily our application is a little bit simpler. We don't tend to run out of RAM, which is really good. So I'm not going to talk about hard disks. Operating system, runtime environment, not execution environment, runtime environment. There's going to be some language games that we play with this component, but this is basically the part that's not the operating system itself, but that ends up essentially being Docker, right? This is the part that philosophically finds its way to being full containerization of the application. But before we get to full containerization, it is, for example, just the environment manager for our Python once we start using Python. So let's get to the Python. User interface, because we need one of this in this application. It's definitely a user application, so we're going to have to find some way for the users to put their paws on this thing. Scripts, glue, right? The glue language that glues all these other components together and is the thing that embodies all the app logic. That is not the model itself, right? But basically everything else. Data, what a concept. We need the data to come from somewhere and probably go somewhere. Right? Model. Now, this is the part where optimization folks are familiar, right? They can do data and model and solvers in their sleep. And obviously the solver is after them all. Generalist developers of varying disciplines and skill sets will find this stuff that they can do in their sleep, right? The stack up until the model. There's actually a lot of commonality here. You can shake a lot of hands across this little spectrum here, right? And I'm not going to defer very much to this artificial separation between like the operations research people here who do the model and then the other people here who make everything work. No, we're all going to pay attention to every component required to make an application run. And that's it. So because we'll be returning to something like this analysis of the tool chain, which is the word I use to describe it, later in a video that follows the entire Lego application video series, we will be coming back and having quite a nuts and bolts conversation about each of these components in a more kind of inside baseball analysis to really see, well, heck, where can you find all that speed that you're missing? Because we're going to do that later, we're not going to do it now. We're just going to satisfy ourselves that there are some questions you might want to ask yourself or your team around each of these components. I've written the questions down, and the second sections are just some very basic and very limited and not comprehensive lists of things you could stick into each of the slots, right? So we have a bunch of solvers here, a bunch of algebraic and other modeling tools here, so on, so on, so on. Good, that's it. And that's where we begin. And these things, if we call them our optimization app components, well, someone in the full stack community might say, hey, show me those things as a stack. And that would look like this, right? The same 9 components, but just with the frothy user interfacey stuff on top, and then your hardware down below and everything else in the middle, like a good hamburger, right? The question we need to answer is the Lego app, right? What is it made up of? And to get to that answer, by the way, this nice Zoomity thing here, this is the whimsical whiteboard software. I like it a lot. It's just a little website. And I will paste this link into the GitHub repository in the description of this video below. And you should be able to just click through and take this and steal it for yourself. And if you steal it for yourself, just be sure to remove all references to Lego, and then you can tell your boss that you made this, and you're very welcome to do that. So now that we know the slots that we need to fill, we will have that conversation first, but we also admit that we don't fill them all at once, that there's this iterative process by which we end up with our final product. All right. And that's it. There's no more. There's, once we've done that, we're done with the video, we're done with the whole architectural conversation. See, it is pretty straightforward. But let's first focus on this initial scope, or the initial hope for what we ultimately will slot into each of our various slots here. So it gets super easy, super boring, super fast, right? I have a little Mac Mini M.2, everything's M.2, M2 Mac Mini computer with 8 gig of RAM, and obviously it runs Mac OS. And for this exercise, it suffices. So I'm going to just leave it on that hardware, right? We will ultimately containerize this, but not until the very last step. And the reason I do that is I want this to be as accessible to the whole range of technical personas that might be interacting with this video series. And I just have a spidey sense that tells me that containerization is one of those sort of like, oh, if you put that up front first, which we probably would containerize earlier on in a proper team out there in the wild, but we're just not going to do it until the very last moment here, right? And the only reason we're doing it in this case is so that anyone can take this and deploy it on any hardware, regardless of other choices that I've made. Good. So we'll get to containerization last. Streamlit is going to be our user interface. I like Streamlit very much. If you haven't heard of it, Google it. It is a Python-based web interface generating framework, which just rocks and fantastic, and you'll see that it rocks. We're going to use Python as our glue language that glues all these components together. We're going to keep our data simple. It's just, even at the very end of this whole exercise, it's still just going to be a collection of CSV files, and some of those CSV files, the very, very big ones, are going to be converted into the Ample native flat file text format, which is, you can open it up, you can read it. It looks almost like a CSV file, but it just reads so much faster. Ample is what I'm going to be building this model in. You do you. If you want to follow along with this, I'd be curious to see if anybody wants to fork the repository and implement this in something other than Ample, because I'm going to make some claims about Ample performance and Ample speed and Ample this and Ample that, and I'd love those claims to be challenged. I'm an Ample fanboy because, for 6 years I was paid to be, and some things stick in your DNA, and I want to be scientifically honest here. So please, I'm probably not the best person in the world to use other than Ample for a, like Pyomo or something like that, to speed freak something like to the umpteenth degree, because I think I've learned a bunch of tricks relative to Ample. It would be interesting to see if somebody wants to fork it and do it in GAMS or in Pulp or Julia MP or whatnot. Anyway, conversation for another day. So, and Highs is the excellent, I am astounded by how good Highs is as a solver. Highs is the solver that we end up using happily because we can, because we did everything else correct, and because Ample really crunches down on the problem size, has pretty powerful pre-solve. See, there I go again with Ample stuff, right? But Ample does do that. It has a very aggressive pre-solve, which by the time it hands the problem to any solver, Highs in this case, the solver doesn't have that much of a big job to do, which is really, really welcome. But we do experiment with Cplex and with Gurobi along the way. Okay, so if this is our initial scope, or our initial hope for what we would like the final application to look like, then we have to step-by-step walk our way there, right? And that's really this downward arrow speaks to a build order. We're just going to go very quickly down this cascade. These are just the titles of all the videos to follow this video in which there is a change or an addition made to the application's tool chain, right? Because we don't make a change in videos through 9 to 11, right? But we do in 8 and 12 and so that's it. In your case, you're just going to have some other sensible milestones at which you're fiddling with the core toolchain. Okay, so these iterations, we're just going to walk this cascade until we end up with what we end up with at the bottom, and then we're done. So the way that I'm using color here, just FYI, is that if something is colored, it means it's either appeared for the first time or changed, right? So that means in the first iteration here, we sit with, let me just get as carefully close as I can. In this first iteration, we decide upon my little Mac Mini's M.2 silicon. It's 8 gig of RAM and Mac OS. That's the last time that those will ever be colored, because we just don't change them for the rest of the app. We don't have anything in the environment box or the UI box or the glue language box. We only have some data by way of CSV file. That's literally it. That's the first iteration, is we start with our CSV files, nothing else. We have no model, we have no solvers. Next iteration, everything the same except we have the beginnings of a model. in ample. We never change out of ample in this, but you might start with something other. You might start with ample, you might go someplace else. Okay. The next iteration is we introduce our scripting language, our glue language. You'd be like, hang on, that's ample. I thought you said Python. Yes, we'll get to Python, but it's just so easy without even lifting a finger, for me at least, to use the ample scripting paradigm. So it's just like scripting language that is also interpreted by the ample interpreter, just keeps it really tight. And just for the first couple of moves, I'm going to do that before we go Python, just to show that there is an option, right? That's it. The next iteration is we build that sexy little user interface, but not in Streamlit. The very, very first user interface that we're going to build is a text-based, good-looking little text file that a user can open, and you can go and change a couple little options in there if you like, and it's all readable, hopefully. And that's it. You close the file after saving it, and then you run the thing, and that's the interface. And it's obviously very bare bones and nothing close to what we'll have in production, but it is enough to give a non-technical person access to what it is we're working on while we're working on the application. It's actually a very good idea to use minimum viable little interfaces like a text-based interface. Anyway, I offer it to you, and little bonus, it contains, for real, a unicorn. We'll get back to the unicorn. So what happens here? Well, nothing changes here except question mark. We start experimenting with our solvers. We start iterating through Cplex, Gurobi, highs. In the next iteration, we alight on highs at the same time as we swap out our scripting paradigm for Python proper. Now we've got a ample core model wrapped in Python, and with Python we introduce the Conda environment manager for Python, just because I want to, just because you might never get to Docker, but if I introduce this concept here and you haven't played with Conda before, you say, oh, it's an easy way to just keep your dependencies and things nicely lined up, and that'll make me look super smart to the rest of the team that I've just been hired into. Cool. Once we have Python in place, we can do this Streamlit user interface, which is what we do. And that's basically the final component of the application. The only thing we then do in the final iteration is containerize. We say Docker here. I'm actually going to use Docker Compose, right? Because Docker Compose is so beautiful and elegant. And that is it. And we end up with the final version of our toolchain. And that's a great success. Now, one thing to note is this final version of the toolchain is exactly the same as the one we thought we'd end up with. A couple of reasons for that. One is there's only one developer involved across the whole toolchain here, and that's me. That's fairly rare in the commercial world. Also, I get to control all of the environment here. There's no one going to barge into my office and say, oh, wait, something just changed. And three, I've rehearsed this before, so I know where we're going with it, right? And that's important to note. We can't, in real life, know everything up front. And I'm just going to say that out here. That's why we state at the beginning what we think we'll end up with, what we hope to end up with. But we're prepared through these iterations along the way to make little pivots and adjustments, because reality ultimately always bats last. Okay, that's it. Now, with all of this done, we are ready to unpack our data. I hope this has been useful. If anything, I know it's been colorful. And I'll see you in the next one. Take care.